So recently I saw a challenge by a YouTuber called Web Dev Cody, and his challenge was to write a kind of quiz that placed a random colour on the screen, gave you three different options, and for you to try and guess which of those three colours it was. The idea being is to see if you can um, learn to understand how colours um, look, or to recognise colours from their hex colours. Now, from a GCSE, even A-level point of view, that's probably a little bit too advanced. But I thought what would be a nice thing to do would be to perhaps look at how we might just generate a random hex colour. And I thought we'd start by doing that, first of all, in the OCR exam reference language interpreter, then move on to Python and C Sharp and Visual Basic, and then up the game a little bit by creating the program in vanilla HTML, JavaScript and CSS, and they're going to be all part of a playlist that I'll be putting together shortly. So let's start with OCR. So John Williams, as we can see here, has kindly put together a nice IDE for students who are studying OCR that effectively allows them to practice their OCR exam reference skills, and it's a very nice way of doing so. So I thought that I would use this as a tool to undertake this task. So having a look at the task, one of the first things that we need to do is understand, well, how does a hex colour look? And a hex colour effectively starts with a hash, it's a string, and then it has 6 digits. Now these are hexadecimal digits from 0 to F, and we know from our studies that that is from 0 to 15, or 16 different options. And the first two represent the red colour, so the red is a figure between 0 and 255. The second two are green, and the last two are blue. So it comprises of 2 hexadecimal digits, each one for the red, green and blue, RGB. But there's no spaces in it, but I was just trying to explain the process. Now, one of the first things that we need to think about is how on earth do we get a how on earth do we get a decimal number or a denary number and convert that to hexadecimal? And how on earth are we going to get this random string? So I'd like to do this in 2 separate stages. The first thing I'd like to do is to work out a way to convert a denary number between 0 and 15 to a hexadecimal number. And there are a whole host of ways of doing this, and it really depends upon the exam board, the examiner, but I'm going to show you the way that Web Dev Cody did it, because although I initially thought this might not be the best for GCSE, it is a very straightforward way of doing this. So the way that we can do this is by creating what I would call a lookup table, and we can create an array of for our hexadecimal numbers. And I'm just now going to copy these. Whoops. And so we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and you remember from number theory that this is now A represents 10, B, C, D, E and F, and we don't need any more of those. So this sets up an array. Now we can keep it like this, but the reality is that because these are single digits, if we remember that a string is simply an array of characters. So what we can actually do is just create a simple string here instead. So that's what I'm going to do, because this is just an array of individual characters, and we can see that, for example, so we can do print lookup at index 10, which should give us A. Let's run that, and it does in fact give us A. So if we then did 15, it should give us F. Now, of course, it will give us an error if we try to go to 16 or below 0. Let's just check 0. That should be 0, which you can see here it is. So we know that we can do that. So the next thing we need to do is, well, how do we get a random number? Because we don't need to get a random string. What we could do is get a random number and then concatenate that with another random number and concatenate that with another random number, and we can do that 6 times. And if we're thinking about repeating something, we would use a loop, and of course we know that the different loops are while, do, or for loops. Now, because we know that we want to do it 6 times, then it seems more appropriate to do a count controlled loop or a definite controlled loop. But we'll come back to that later. The first thing we need to do is generate a random number between 0 and 15. So we can say something like that is equal to, and in OCR ERL, we can just put the start number and the final number. And at this point, I would just print R&D. The way to check that, we now want to check that effectively, hopefully we're going to get 0 and 15 and the variations in between. So let's just play. We've got a 14, 13, 3. There we have a 15. So we know that it is 15 is inclusive. And we know that it's 0 inclusive. So what can we do with that now? Well, we can say that the hex digit is equal to the string of no, I'm lying to you. We can say it is the lookup at index R&D, and now let's print out hex digits, and then hopefully we'll get C, D, B, 9, 5, 3. So we're going down to 0, so we've checked that it does reach 0. See if we can find an F here. There we go, we have an F. So we know that it's inclusive 0 to F. So we now have a way of getting a single hex digit. Now, from a decomposition point of view, we could do a function, because this is going to return a value. So we're going to call this get random hex digits. We're just going to tab these in, and we will then return hex digits. And don't forget, then we need to do our end function. So we can now test this function. I'm just going to get the spelling of it correct. We can say something now, digits equals get random hex digit. Now, of course, remember this is a basic IDE, so it doesn't have IntelliSense or other ways that an IDE might assist you, but I think it's fantastic. I think it's really helpful for students to have this way of being able to play with pseudocode. And we can see it's printing the various random digits that we have. So we can now get a random digit. Now, we said earlier on, what we can do then is we can get 6 of those. So we know that our color string, I'm going to call it color string, is always going to start with a hash. So I'm going to initialize color string to be a hash. And we want to do this 6 times, and so we can say for C equals 1, 2, 6. Now remember, in pseudocode, it is 1 to 6 inclusive. So in Python, for those of you that have might think about Python you would have to do for I in range, you would put it in I in range 6, but that would give you 0, 1, 2, 3, 4, 5. However, what we're doing here is saying 1, 2, 6, so we need to do this 6 times. And what we're going to do, if you think about it, is we want to get this digit, and then we want to concatenate that onto the end of color string. So we can say color string is equal to color string plus digits, and we need to do next C, and then hopefully we can then do print color string, and let's see what that gives us. And we can see here 1, 2, 3, 4, 5, 6. That's given us a random hexadecimal color, and that's how you would do that in pseudocode. Now, of course, it might be a better idea for you to say function get a hex color, and we can, so that's a problem with that, and as we've deleted it, for some reason the undo doesn't work, but that's not a problem. We can do that again. We can say for C equals 1, 2, 6, digit equals, don't want to double those equals there, of course. Okay, and then we can say color string is equal to color string plus digits, next C, and then we can return color string, and don't forget our end function. And now we can say, random color is equal to get hex color, and we can just print random color, and as we can see, it all works perfectly. Now this is probably a little bit overkill for GCSE. We could probably just write this all in without any functions, but I thought that I would take you through it without a function, and then how to put them into a function. And that is a way to do that. Now, making it as a function is quite important in my opinion, because there are many ways to get the random hex digit. This is just one of them, but the beauty of doing it this way is if I find a more simpler way to do this, I can change this function here. Provided it returns a hex digit, this function doesn't care at all how this function works. It simply knows that it expects to give it nothing. We can see there are no parameters sent to it. It has no arguments, and it returns a digit. Now, I don't believe in this case that there's any really worrying about error checking, because we've confirmed that the random number is always going to be 0 to 15, so we know that that's not going to be below 0 or above 15. So that's how you can do that in OCR exam reference language. If this lookup table to you seems to be alien, then we can change this code and use basic conditional statements, if and else if. And we can do that by stating we can start with a hex digit, this time setting it to be a empty string. We still want to get a random number, and we still want to return that hex digit. So what can we do here? We can say that if the random number is less than 10, then what do we want to do? We want to say then, and we want to say our hex digits is equal to the string, because remember that random is an integer. We want to send back a hex digit as a string, so we can do string of our random number. Else, if R&D is equal to 10, then what do we want to do? We can say that hex digits is equal to A, and we can do this A, B, C, D, E, and then for F we know that it has to be the only one, so we can just have an else at the end, and don't forget our end if. So if it's 10, it's A, if it's 11, it's B, if it's 12, it's C, if it's 13, it's D, if it's 14, it's E, and if all else fails, it must be F. So now we've changed this whole procedure here, but from this procedure's point of view, it doesn't care. Let's see if that works. Okay, so we've got, did you mean to use equals equals, and there we go. So of course these are comparator operators, so they should be equals equals, and let's try and run that again, and of course we have 1. And again, that's often an error that we make when we're coding. Don't panic when you see the red error message of doom. Just look at the error message, see what it says, and if necessary keep playing until you get the right answer. Now of course in an exam you don't have the privilege of being able to get that red error message of doom, and so they're unlikely to penalise you if you had given the answer that I had given there. But if this was worth 6 marks, the worst they might do is knock you off a mark for it not being 100%. But it would be cruel, but they could do that. So there's a second way of doing this particular task. There is a third way, but I'll leave that open to you. But I'll just remind you of the commands of ASC, which converts a ASCII character to its number, and CHR, which converts a number to its ASCII equivalent. That's the end of this. The next in the play series, or in the playlist, will be the Python version.